Most companies deploying AI right now are burning money, not because the AI doesn't work, but because they're using a $10 tool to do a $1 job. And the fact is, you may not even need AI. Token costs are now showing up on CFO dashboards, and nobody can really explain why the ROI isn't there. But today I'm going to tell you exactly what's happening, and I'll give you a framework that will immediately change how you think about AI infrastructure costs. So today I'm going to explain why you don't need a Ferrari if you're only going to drive to church on Sunday. The AI vendor world doesn't tell you that compute is a spectrum. It runs from almost free at one end to eye-wateringly expensive at the other. And many organizations are deploying at the expensive end of the spectrum for workloads that just don't need to be there. The chatbots are a tiny fraction of what AI actually does. And the real value of AI comes from the stuff that nobody ever sees. Classification models, for example, sort thousands of documents. Extraction pipelines can pull out structured data from invoices. Anomaly detections can catch quality issues on a production line. These are the real killer productivity benefits of AI. And by focusing only on cloud-based chatbots means that you're paying for things that you probably don't even need. So let's walk through this hierarchy. There's 3 levels, 3 very different price points, and the business logic for knowing which one to use. Cloud GPU. At the top of the stack, you've got Cloud GPU. These things are extraordinary pieces of engineering, purpose-built for one thing: parallel compute at massive scale. These are the things you need when you're training a large language model or running real-time inference on something with tens of billions of parameters. And of course, the price reflects that. A single H100 instance can cost anywhere from $3 to $8 per GPU hour. Production deployments often cluster dozens of these together. So before you know it, you're looking at 5 or 6-figure monthly builds. Now, is that justified? Sometimes yes. If you're doing genuinely GPU intensive work, training foundation models, running complex multimodal reasoning, or processing massive unstructured data sets in real time, yes, cloud GPU is probably the right tool. But the question you need to ask is your actual workload genuinely GPU intensive? Most of the time, the answer is no. Most of what businesses call AI is not open-ended reasoning. It's narrow, well-defined tasks running at high volume. And for those, you're paying for a Ferrari to go to church on Sunday. In the middle of the stack is the cloud CPU. These are standard compute instances, the kind of things that cost cents per hour, not dollars. And for a huge category of tasks, this is all you need. Think about what's actually happening inside most enterprise AI deployments. Document classification, structured data extraction, simple summarization. They aren't creative writing problems. They're pattern recognition and decision logic. They don't require a 70 billion parameter model running on a GPU cluster. They do require a well-optimized, smaller model running on a CPU because the cost difference is enormous. Cloud CPU still makes sense when you need elastic scaling, when volumes spike unpredictably, or when you're running workloads across geographies and you don't want to manage the infrastructure yourself. That's a very legitimate use case for the cloud. But the mistake is defaulting to GPU tier when CPU tier would do the same job. Yes, you'll hit throughput ceilings much faster. And yes, the latency is much higher than GPU. But for many business workflows, you may not even notice. But your finance team, however, will absolutely notice when the bill drops considerably. And then there's the option that most people aren't even considering: local compute. The processing power already sitting in your servers, your edge devices, or on your factory floor infrastructure. Once the hardware is paid for, the marginal cost of a decision is basically zero. And there's no cloud egress fees, no per token charges, and no third-party APIs touching your sensitive data. Now let's talk about unit economics. And the number that I want you to think about is a cost per decision. If you're running a task 50,000 times per month, let's say classifying an incoming document, and you're routing that through a cloud GPU, you're almost certainly wasting money. The same task running locally would be orders of magnitude cheaper. And that's not a minor efficiency gain. That's the difference between AI deployment that makes sense and one that gets shut down when the budget review comes around. The cloud is brilliant for what the cloud was designed for: elastic scale, global reach, and frontier model access. But not every task needs elastic scale or a frontier model. So you need to stop treating the cloud as a default option and start treating it as one on the spectrum. And when you do that, your AI unit economics change completely. The AI industry has every incentive to sell you the most expensive compute possible. Your job is to ask questions and push back. Because the truth is, you may not even need AI, at least not in the way that vendors are trying to sell it to you. They're trying to sell you a Ferrari when all you need is a reliable car to get to work. And if you want to know what the most underrated piece of AI hardware on the planet looks like right now, it's not an NVIDIA chip. It's not a data center in Virginia. It's got an Apple logo on it. So in the next video, I'm going to break down why Apple's M-series chips have changed the local AI game entirely. Unified memory, neural engine performance, and power efficiency. Big tech wrote off Apple in the AI race, while Apple was busy eating the whole field for breakfast. Subscribe so you don't miss it, and I'll see you in the next one.